Hey everyone, today we're tackling stoichiometry, the math of chemistry, by solving this propane combustion problem. Think of it of like following a recipe. If a recipe says 2 eggs plus 1 cup of flour makes 12 cookies, you can't just throw in random amounts and expect the same results. Chemical equations work the same way. The coefficients are like recipe ratios. They tell us exactly how much of each ingredient we need and how much product we'll get. Let's dive in. So first and foremost, we need a recipe, which is aka the balance equation. So we know that propane, C3H8, let's rewrite this actually, it's a little nicer. C3H8 reacts with oxygen to form carbon dioxide and water. One way I like to make sure that my equation is nice and balanced is for the left side, I have all the equations, all the elements right now. For the right side of the equation, I have all the elements right now. Try to figure out a way to make sure that they're equal to one another. So we have carbons on the left side, hydrogens on the left, and oxygens. We have a total of 3 carbons, 8 hydrogens, 2 oxygens. Now for the right side, we have carbons, hydrogens, oxygens. Same idea. We have 1 carbon from the carbon dioxide. We have a total of 2 hydrogens from the water. And for the oxygens, it's going to be 3. 2 from the carbon dioxide and 1 from the water. Now, if we look at left and right, we see that they're not equal to one another. So what I want to do is I'll start with the carbons. To make sure that I have equivalent amount of carbons, I'm going to put a 3 here. So now on my right side, I have, instead of 1 carbon, you have 3 carbons. And your left side, you have 3 carbons, so you're good. But the oxygen's changed. Instead of it being 3, it's now going to be 3 times 2, which is 6. 6 plus from the 1 from the water, it's going to become 7. Okay, now we look at the second part. Now I want to get my hydrogens and oxygens balanced out. I'm going to go with the hydrogens. So what I'm going to do is I'm going to put a 4 here. 4 times 2 is 8. So instead of having 2 hydrogens, you're going to have 8 hydrogens, which is now equivalent to the left side of the equation. And my oxygen is now changed. Instead of having 7, it's going to be 3 times 2 from the carbon dioxide. You're going to have 6 oxygens there, plus 4, which is what? 10. Now I have 10 oxygens on the right. How many oxygens do I need on the left to get 10? I have to get 10. So the only way I can get 10 is by putting a 5 over here. 5 times 2 is going to give you 10. Now, let's check our work. We have 3 carbons from the propane, 3 for 3, correct? And we have 3 on the left. We have 8 hydrogens on the left, 4 times 2 is 8. And we have 10 oxygens on the left, 5 times 2 is 10. And on the right, 3 times 2 is 6, 6 plus 4 is 10. So we have our balanced equation. After we have our balanced equation, we'll move on with part A of the question, right? So part A states what? If 2.8 moles reacts with excess oxygen gas, how many grams of carbon dioxide will form? Now, here's where mole ratios come in. Think of them as unit conversion highways. Our balanced equation says for every 1 mole, right, for every 1 mole of propane, it will produce 3 moles of carbon dioxide. So we build a bridge. 2.8 moles of propane will give us what? Will give us 3 moles of carbon dioxide over that 1 mole of propane, C3H8. The moles cross out. So moles of propane cross out moles of propane. And your answer is going to be 4. That's 8.4 moles of carbon dioxide. However, the question doesn't ask for moles. It asks for grams. So a good way to understand this is it's like converting between units. Let's say, for example, cups and ounces. So we want to make sure that instead of being in moles, we have to convert it to grams. To do that, what we must do is we have to now convert from the moles that we have from the carbon dioxide to grams of carbon dioxide. And one way to do that is by first understanding how many grams are in 1 mole of carbon dioxide. Let's break down carbon dioxide. So let's take this arrow, bring it here. Carbon dioxide has 1 carbon and 2 oxygen. How many grams is 1 carbon? 1 carbon is going to give you 12 grams. 1 oxygen is 16 grams. Because carbon dioxide has 2 oxygens, it's going to become 2 times 16, which is going to be 32 grams. 12 and 32 is going to be 44 grams. So for each mole of carbon dioxide, it's going to be 44 grams total. After we have now our 44 grams, and we know that, we just take the moles we have from before. So we know that we have 8.4 moles. We take this, We bring it down here. We do 8.4 moles of CO2 multiplied by our 44 grams of CO2 over 1 mole of CO2. We now know that our mole will cross out with the mole of CO2. And your final answer, after you multiply 44 multiplied by 8.4, you're going to get 369.6 grams of CO2. So the answer for part A is going to be 369.6 grams of CO2 will be produced after 2.8 moles of propane. Now, a quick recap. First and foremost, when you get a problem like this with stoichiometry, you have to get your balance equation. After you get your balance equation, you have to use your mole ratio to convert whatever moles you need to do, and you have to reread the question to make sure if they're asking in moles, if they're asking for in grams. And after that, convert it into the units that is desired, and that'll be it. If you have any more questions, if it comes to Gen Chem, OChem, math, and more, book a session with me, and we'll get it done. Have a good day.